Hi, welcome. This is Joanne Chung from ADAC Lab. This demonstration talks about a real-time cyber-physical microgrid test system that is developed at ADAC Lab. It's called Renewable Energy Management in Microgrid Simulator, REMuS in short. So we will firstly explain what is REMuS and how does it work, following by a demonstration. Finally, we'll wrap up the demonstration with some takeaways. REMuS is a real-time cyber-physical microgrid test system that is designed to aid distributed microgrid EMS developments and to provide proof-of-concept microgrid EMS algorithm validations. The diagram on the left depicts the overall system architecture of a 5-bus microgrid implementation. The REMuS has an independent cyber and physical layer that is designed for cyber-physical code simulation. The cyber layer consists of 5 BeagleBone Black microcontrollers, 5 onboard converter MCUs, and the graphical user interface. The collaborative distributed energy management system is deployed in the BeagleBone Black microcontrollers that is located at each microgrid bus. Each BBB collaborates with its neighbors to estimate the global information in order to come up with the optimal operating point for the physical devices. The onboard MCUs will then execute the dispatch commands received from the BeagleBone Blacks.
If we take a closer look at here, these are 5 BeagleBone Black microcontrollers that is controlling each bus. So in this REMuS H platform, we have 5 buses. Each bus represents a household, and we have 5 BeagleBone Black controllers. So in this graphical user interface, we have full control of the entire system, and we can visualize the data that is transmitting in the communication network. And here in the remote login window, you can see all the BBB talk to each other through the peer-to-peer communication. In order to do the full 24-hour day-ahead energy scheduling, these 5 BBB will take around 1.5 minutes to finally calculate the optimal result. So as shown here, it says all the BBBs have finished the calculation for the next day energy scheduling problem. So all of these results is automatically sent to this graphical user interface. So within this interface, by clicking the Power Dispatch tab, we can see the optimal next day energy dispatch command is received by the graphical user interface. So here is the schedule for the grid, and here these 4 are the schedule for the household battery for each house.
The physical system consists of 5 DC-DC bidirectional converters so that it can mimic the bidirectional power flow that is across the microgrid nodes with distributed energy resources.
And in this table, we have 5 DC-DC converter that is connected to a power supply and load. So here we use the power supplies to emulate the behavior of the renewable generating unit, and we use the load to emulate the power consumption within each household.
With both cyber and physical layers in place, the user is able to conduct hardware-in-the-loop simulations to prototype or to demonstrate their desired distributed microgrid EMS algorithm. The real-time microgrid dynamics are simulated by the software model implemented in MATLAB Simulink environment, and the simulated dynamics are then sent to the BBB microcontrollers in parallel to the software simulation. The BBB microcontrollers will forward the dynamics to converters to execute and adjust the dispatch commands if needed.
Software solver, which is the REMuS S, running behind the graphical user interface. In this simulation software, we can simulate the transients in the power system and all the electricity and voltage within the system. After we initiate the real-time simulation, the graphical user interface will invoke this REMuS S software simulator. If we take a look at the physical system, so here we have a DC microgrid setup. So each BeagleBone Black controller will send the simulation information to each DC-DC converter to tell it how to interact with other nodes in the grid. Right now the simulation time is 10 o'clock in the morning. We can see these red lines are the real-time simulation data that is fetched from the TI DC-DC converter. We can see that the real system is following closely to the day-ahead dispatch command. And here in the physical system, we can see the node 2 is injecting current to the grid. Because the node 2 is injecting current, then this purple line represents the output of the grid. The current will decrease correspondingly. The entire physical system is following the REMuS simulators.
In this demonstration, a real-time cyber-physical microgrid testbed system, REMuS, is introduced. REMuS test system is a highly modular and scalable system. It can easily adapt to different systems with arbitrary numbers of nodes at a very low cost. REMuS is equipped with an independent cyber and physical layer for cyber-physical code simulation, which enables fast microgrid EMS algorithm prototyping. The hardware-in-the-loop simulation capability aids the microgrid EMS algorithm development and demonstration. Thank you for your time. If you have questions, comments, please feel free to contact us. Please visit our website for more demonstrations and information. Thank you.